Okay, good morning everyone. So we're going to carry on with shifted conic sections, but this time we're going to do an ellipse and a hyperbola. Now we know that the general equation of an ellipse is, say, x squared plus, rather x squared over a squared plus y squared over b squared should be equal to 1. Okay, now this here is the case if your this is an ellipse, yeah. So this here is a case if your major axis is in the x-axis. Okay, so this here is a major axis because that's the longest. Then this is a minor axis because it's the shortest. So that is why the x here, okay, rather the a here is underneath the x because the major axis is in the x-axis. Then the b is in the y. If your ellipse was to be oriented like so, okay, where your major axis is in the y and your minor axis is in the x, your equation would have been x squared plus, rather, your equation would have been y squared over a squared plus, let's see, x squared over b squared should be equal to 1. Okay, so that would have been the case. Now, because we're talking about shifted conic sections here, everything that we did on the previous videos is just going to be the same. It's just going to be applied here. Okay, by that I mean to say, talk about on x here, what are we going to do? If this is your xy axis, then we're talking about a shifted ellipse. Then it's not going to be centered at the origin, but it is going to be centered somewhere else. Okay, it can be here, wherever it may be. It can be here, it can be there, wherever it may be, as long as it is shifted. Okay, so the equation would then be given by x excuse me, x minus h, then we say squared over a squared plus y minus k squared over b squared should be equal to 1. Okay, this is a plus right here. So that is the equation. Okay, let's just attempt to do some examples, then I believe by then we'll be able to get the information. So we're being told, find the center, vertices, and foci of the ellipse. Okay, so the equation is the equation is 4x squared plus 9y squared minus 8x plus 36y plus 4 should be equal to 1. Okay, now when we look at this, obviously this doesn't look like the usual conic section that we know of, that is rather the general equation of an ellipse. So lucky for us, they've actually mentioned in the question that this here is an ellipse, so we need to expect what we should find at the end. Or rather, if it's hard to derive, we need to at least try to just make it move along a certain path as we derive. Okay, so let us first start by grouping the like terms together, always. Okay, so this here, and by the way, another thing we should note is imagine they didn't mention this is an ellipse. How would you know? Like I said, this here is x squared over a squared. This here is the general equation of an ellipse. Then this is y squared over b squared should be equal to 1. As you may see, the x has a squared, the y has a squared as well. Okay, so it can either be a circle or an ellipse, because with a circle it has x squared plus y squared should be equal to r squared. Okay, yeah, that is the general equation of a circle. So at least we can know saying this isn't a hyperbola. Sorry, this isn't a parabola. Why? Because the general equation of a parabola only has one of them, that is to say either x or y. Only one of them has a square at the top. Okay, but in this case two of them have. So let's group the like terms together and then we carry on. So this here is 4x squared, then this 8 goes that side, we're going to have minus 8x, then we go for y, so it will be plus 9y squared, then what else, plus 36y, then we take this 4 to the other side. Okay, so this here will be minus 4. What we're now going to do here is factor out the 4. Okay, to make things simple here, what we need to be looking at, or rather how we need to be looking at it, is like this. This here should be resolved separately and this here should be resolved separately, just as we did in the previous videos. So if we're resolving this, then let's factor out the 4, assuming that you've forgotten about everything this side. Yeah, so for now, let's just forget about this. So let's factor out the 4. So the 4 has been factored out. Then we open brackets. Then we say x squared minus. Then this would be a 2 because 4 times 2 is 8. So we have 2x. Then we close the brackets. Okay. Then we say plus. Then we do the same here. Please, I'm not yet completing the squares here. I will, but not yet. Okay. I'm just first trying to simplify. So if we're completing the squares, I'd have left a space here. I'll get to that. So this here is 9. We factor out the 9. Then we do that. So when we say y squared, then we say plus. And when we factor out 9 from 36, that would be, what's that? A 4. So this here will be 4y. So this is a plus. So 4y should be equal to negative 4. Okay, negative 4. Then from here, what we're going to do now is use the completing the square method to evaluate this and this as well. So for now, let's deal with this. Okay, so we take the 4 out, then we open brackets, then we write x squared, we say minus 2x, then we get half of what's in the middle, then we square it. Okay, that's why we leave our space here. So let me say plus, we leave a space, then we close brackets. Okay, then what we're going to put here is half of what's in the middle, which is half of 2. So which is 1 squared, which of course is just a 1 because 1 times 1 or 1 to the power 1 is just 1. So there will be a 1 here and then we close. Okay. Then whatever it is that we do on the left, we do on the right as well. Okay. So again, if this here is your 5, this here is your 5, 5 is equals to 5. So if you're going to add divided by 2, this won't be the same anymore. 5 over 2 is not the same as 5. It is not equal to 5. So for this to be equal, I also need to say 1 over 2. In other words, what we do on the left, we do on the right as well. So what did we add that wasn't there? We added a 1. Okay. So meaning to the other side of the equal sign, what we're supposed to add is a 1. But hold on. This isn't just a 1. Okay. So just a 1. It would be a 4 times 1, which would be 4. So meaning as we add something towards the right, or rather the other side, we're going to add 1 times 4, which is just a what? A 4. Okay. So meaning on the right side, we're going to add 4. Because this wasn't there at first. So because we've added it, it's going to multiply with 4. So meaning we've added 4 that wasn't there. So meaning we're supposed to add 4 on the other side as well. So we now do the same. Actually, before I even get to this side, I want us to get familiar with this first. So now let's evaluate this. Okay, let's change this. So this here will be a 4. Then we open brackets like that. Then to simplify this, it can be rewritten as x minus, because there's a minus here, 1 squared. So all that I did was get the first value. Then because there's a negative here, I put the negative here as well. Then I got the last value. Okay, just first value, negative, last value. And then you square it. Why? Because if you were to get this, and then if you were to expand it by multiplying them, okay, you still end up with having what? This. So that's the idea right there. If there was a positive here, would have put a positive here. So yeah, that's the idea. Then there's a square there. And for here, we're done regarding x. Now let's move on to y. Okay, let's use completing the square method, which is what we've done on x. Okay, so looking at this this equation right here, we've already factored out the 9. Okay, then what we're going to do is rewrite everything. So we say y squared, then we say plus 4y, then we say plus, then we leave the space, we close. Again, what we're going to fill in this space is just half of what's in the middle. Okay, and what's in the middle? That's 4. Okay, so this is 4 times 4 divided by 2, which is just a 2. Okay, but we're not just going to put a 2, we're going to say 2 squared, just as we did here. This is supposed to be a 1 squared, but 1 squared is just the same as 1. Okay, now again, because we've done something on the left, we need to do the same on the right. We've added something that wasn't there. We added half of 4, okay, which is 2. Then we had to square it. Meaning on the other side, we'll say plus 2 squared. But hold on, because we added a 2 squared, this 2 squared is also going to multiply with a 9. Okay, so say 2 squared times what? Times 9. That is what is going to be added this side. So 2 times 2, which is the same as 2 squared. Okay, I'll evaluate this later. Okay, yeah. So let me simplify this even further. Okay, actually, let me just simplify this. This doesn't look neat. So 2 squared is just a 4. Then 2 times 9, that's actually 4 times 9, that's a 36. So we're going to have 36 on the left side. So 36 right there. Okay, now let's simplify this. So we'll put a 9 there, then we open brackets. Then we're going to take the first value, then we square it, then we get the last value. Actually, we don't square it, we just get the first value, which is y. Then we also get the last one. We close brackets, then we square, just as we've done here. So we say y plus 2, we close brackets, and we square. Okay, again, this is just a simplified version of this. It's the same thing, but just simplified. Y, should you get y plus 2 and multiply it by y plus 2, you're just going to get this. Okay, yeah. So excuse me, what we're now going to do here is add this up. Oh, by the way, what's that? I've forgotten. Did I forget something? Let's see. Yes, I did. Okay, remember, this 4 that we have here is not as a result of completing the squares. Yeah, this 4 here is as a result of taking this first 4 in the equation. Where in our equation we first had a 4. This is a plus. Okay, so this 4 here, when taken to the other side, it became a negative 4. That's why we have it there. So meaning we have negative 4 and we have that plus 4, which came as a result of, let me not put it there, let me put it here, right here. Okay, negative, yeah, negative, actually positive 4, which came as a result of that 1 here. Okay, I don't know if you see it. This 1 here was added, but this 1 had to multiply with the 4. So we have 1 times 4, and because we've added 1 plus 1 times 4 on the left side, meaning we're supposed to add 1 times 4 on the right side. So here there's a negative, then here it's plus 4. Okay, I don't know if you get that, but let me try explaining this one more time. Yeah, so this 4 here, which we have here with this negative 4, is just a result of taking the constant towards the right side, and then it had to change the sign. Okay, then this other 4, this one right here, came about as a result of this 4 that we've added this side. Why? Because this 4 is going to rather this 1 that we've added this side, because this 1 is going to multiply with the 4. Okay, and because whatever it is that we do on the left, we do on the right as well. So this 4, so when we evaluate this, the answer will be 36. Why? Because this is negative 4 plus 4, so that's just a 0. Then the remaining one is 36. So what we're now going to do here is, remember we're doing this just so that we should have the general equation of an ellipse. So we're going to say divided by 36, divided by 36, divided by 36. Okay, so when this goes, we'll have a 1 here. Then when this goes, we want 9 into itself, that's 1. 9 into 36, that's a 4. Then 4 into itself, 1. 4 into 36, that's a 9. So what we're going to have finally is x excuse me, minus 1 squared over 9 plus y plus 2 squared over 4 should be equal to what? 1. So that's a plus right here. So what we're now going to do here is, let's simplify these so that you should be able to know what our a and our b is. Okay, so we have x minus 1 squared over, rearranging this, 9 is the same as 3 squared. Excuse me, 9 is the same as 3 squared. So we're going to say plus y plus 2 squared over 2 squared, because 2 squared is the same as what? 4. Should be equal to 1. So we've rewritten this in the general equation. Now, how are we able to know that, okay, this here is a shifted conic section? Because of this. Okay, with the general equation, it is just an x here and a y there. But this one has got a minus and a plus right there. So to know where this ellipse is centered at, what we're going to do here is this. We take this and equate it to 0. Okay, so this here is x minus 1 should be equal to 0. Then we solve for x. So x should be equal to 1. The 1 goes to the other side. Or rather, we add both sides by positive 1. So that's for x. We do the same for y. Here, we add this and equate, rather we get this and then we equate it to 0. So this would be y plus 2 should be equal to what? 0. Then we solve for y. So y should be equal to what? Negative 2. So we have our coordinates. We have x, which is 1, and y, which is negative 2. So this here is your h, this here is your k. Okay? So if we're to have our real line, sorry, if we were to have our x and y axis, then at x is equals to 1, it will be somewhere here. Okay? 1. Then comma negative 2, that is negative 1 here and negative 2. So it would be somewhere here, meaning our ellipse is oriented somewhere here. It's rather is centered here. Okay? Has been shifted from the origin to here. So let us now graph it. If we look at it, okay, which one's bigger between 3 and 2? Obviously it is 3. So meaning 3 is our A, meaning our ellipse is having its major axis in the x-axis. Okay, why in the x-axis? Because there's x at the top there. Then this here is 3. So meaning, and 3 is greater than 2. So we're now going to do this. So that there is a 1, this here is a 2, there is a 3, 4, and so on. So we're now going to move 3 units to the right and 3 units to the left. Okay, so that's 1, 2, 3. Okay, we've ended on 4. Then let me just draw some lines. So that's negative 1, negative 2, negative 3, negative 4. So again, starting from here, we're going to move 3 units to the left. So that's 1 there, yeah, at 0. That's 1 there, 2, 3. Okay, so it will stop at negative 2. So don't know if you can be able to see this, but yeah, it's stopping at negative 2. Then our B is, and before I talk about B, let me just draw this line to ensure that, okay, it's visible enough, okay, and it is centered where? Here, because that's where it has been shifted. Excuse me, shifted. So what about our B? What is our B? If we look at it, our B is what? 2. Okay, so what we're now going to do is move 2 units up and 2 units down. So here we've got negative, that's this here is negative 1, this here is negative 2. So this will be negative 3, negative 4, negative 5, negative 6. Okay, something like that. Negative 5, negative 6. So meaning we're going to move 2 units downwards and 2 units upwards. So starting from here, let's move 2 units down. So that's negative 3 and negative 4. And starting from here again, we move 2 units upwards. So that's a negative 1 and that's a negative 1 here and 0. Okay, so meaning right there. So to draw our ellipse finally, it would look something like what? Like so. So we are done. Okay, like I said, they may be looking for a vertex, vertices, whatever it is that they may be looking for. What's important is that you get what's important is that you understand what it is that is going on, and all that you have to do is first graph it, and then you try to get everything from here. So let's get everything from the graph as we've done, because we've graphed it. Okay, so let's get the vertices. So this here is the major axis, okay, and the vertices are the end points. So these vertices that are found in the major axis are called the major vertices. Then these vertices, this one and this one, which are found in the minor axis, are known as the minor vertices. So what we're now going to do here is, let's say major vertices. Let me write it as MV, major vertices. So this will be found at, this is found at the point x of 4 and y, which is negative 2. Okay, right here, that's where they meet. So the vertices would be, the major vertices would be 4 comma negative 2, and this other end here, the vertex, okay, where that point is located. So that would be that end. Let's see, negative 2, for this. Okay, negative 2 and negative 2 there. So that's negative 2 comma negative 2. Then the minor vertices, major and minor. Okay, let me just say small. Okay, for the sake of, okay, let me say BV, because these are in B. Okay, just to make it, just to make that distinction between the two. So yeah, minor vertices. Let's start with the one at the top here. Okay, in X it is located at 1. Then in Y, where is it located at? Let's see, 0. Okay, yeah, so this is at the point 1 comma 0. Then let's look at this other vertices right here, this other vertex right there. So the other vertex there is, let's see, where is it located at? It's located at X, which is 1 here. Okay, in this line at X is equals to 1 and Y is equals to what? 4. So that is that point there. So X is equals to 1, Y is equals to negative 4. We close. So these are the vertices, yeah. So I just hope you guys are writing this down. So let's now find, so we're done with the vertices. Let's now try to find the focus. Remember, for an ellipse, we've got the equation a squared is equals to b squared plus c squared. Okay, where a is the major axis, b is the minor axis, and c is the focus. So let's find where the focus is. The focus is some point. Let me just draw this in green, or excuse me, or blue. So this here could somewhere here, not that that's where it is, but just somewhere there and somewhere there, that's where our focus is. Okay, so I'll get back to that, but just within those ranges. So let's find where the focus really is located. So let's see, we have our A, we have our B as well. Our A is just the major axis, which is what? 3 squared. This right here, started from here to here. Okay, we have to move 3 units to the right. That is our A. So 3 squared should be equal to, what is our B? Our B is just starting from the origin going at the top, which was what? 2. Okay, so say 2 squared plus C. Then let's solve for C. So this will be C is equals to, what is 3 squared? That right there is a 9. Then we say 2 squared, then this 2 goes to the other side. Of course, we are just rearranging everything. So this will be minus what? Minus 4. So 9 minus 4 is just what? 5. Okay, so C, actually this is C squared. Yeah, so this, the C isn't necessarily at 5. Okay, remember the focus has to be somewhere inside, somewhere here and somewhere there. Okay, not outside. As you may see, this is a 5, and 5 is greater than 4. So 5, meaning if we just leave it as excuse me, as it is, then we're suggesting that it is located somewhere here, which is obviously wrong. So what we're now going to do is take the square root, we cancel it out, so that C would be the root of what? 5. And the square root of 5 is less than 4 and greater than 1. So it is just somewhere here. Okay, so that is our C, that is our focus. That's where it is located at. Okay, not just specifically at -5. That's for the x-axis, by the way. Then for the y, it is located in -2, within this range on the line. Okay, this is -1, this is -2, this is -3. So just within the line of -2. Okay, then okay, we found the focus, we find the vertices. What else? I think we've solved everything. Okay, let me try to be quick, then we just do 2 more examples. So I've been told saying the vertices of an ellipse excuse me, the vertices of an ellipse are -7, 3 and 3, 3. The foci are -6, 3 and 2, 3. Find the equation for the ellipse and sketch its graph. So again, sketching it is actually what makes it very easy to solve for everything, because we'll be getting everything from the graph. So this here is our xy plane. Then what we've been told is this, that the vertices are -7, 3. Okay, so -7, let's move to the left. 1, 2, 3, 4, 5, 6, 7. So that's somewhere right here. Okay, -7, then they said 3, so that's moving up by 3 units. 1, 2, 3. So it's just somewhere here. Okay, that's where one point is for one vertex, and the so that's -7, 3 and 3, 3. So 1, 2, 3 to the right, and then 1, 2, 3 upwards. Okay, which is somewhere here. Okay, so we can draw our line here. Now we don't know if it is going to open like this, because it can look like this then yet our graph opens like how? Like so. Okay, so we don't know. But what will help us to know where this graph, how this graph is oriented exactly, is the focus. Because remember, if you're having your ellipse like this, as long as it's in the major axis, okay, that's where your focus will be. If your ellipse looks something like so, then it is within the major axis, okay, that we're going to have your focus, not in the minor axis. So where is this focus located? We've been taught saying that the focus is located at -6, 3. So this is 1, 2, 3, 4, 5, 6. Okay, yeah, 6, 3. So 6, 3 somewhere there. Okay, that's where this focus is. This is the vertex. So because we've known where the focus is, so there's another focus, because of course it's an ellipse and it's supposed to be 2. End at 2, 3. Okay, so this is 1, this is 2. So that's for x, then comma y, that is 1, 2, 3. Okay, so it is located somewhere here. So this is where the focus is, this is where the focus is. Just ensure that you put numbers so that it becomes less confusing that way. Yeah, so I'm just avoiding numbers to make it look neat enough. So yeah, that's where we have our focus there and another focus there. Okay, so we know we don't know exactly where it is centered at, but one thing we know for sure is that if we have our ellipse there like so, then the origin would be in the middle. Okay, so what we're now going to do is this. Let us add 3, because this here is 3 as one of the endpoints. Then this here is -7 as a feathered endpoint here. Okay, so let's add 3 plus -7, then we divide it by 2. When we find half of it, then we're going to find where it is centered at least in the x-axis. So this is -7 plus 3, which is -4. Then we just divide it by what? By 2. Okay, so -4 divided by 2 is just negative what? -2. So meaning in the x-axis, so this is 1, 2. Okay, so it is located at -2, because we've been taught to find the center, the vertices, and everything else. Okay, so you just rub that off. Yeah, so that's in the x-axis. And what about in the y? Where exactly is it? Oh, actually in the y it's in the same line. This here is the line of 1, this here is 2, then this here is what? 3. Okay, so that's where our center is. So meaning this ellipse of ours is located at the center of negative what? -2, +3. Why +3? It is within this line, which is +3, of course. Then our -2 is just half of the entire ellipse. Okay, conic sections are fun as long as you've understood. So don't just go by one method of solving something, because that would be you memorizing, but just ensure that you understand. So what next? Yeah, so at least we know the major axis, we know where the focus is, we know where the center is, but we know where the vertices are, but we don't know what B is. Okay, we don't know if it looks like so, we don't know if it looks like this or like that. Okay, it has to, we don't know its eccentricity. So what we're supposed to do here is find our B. Okay, remember, if this here is your conic section, your ellipse specifically, from the center to one side, that would be A. Then from the center to the other side, that would also be A. Okay. Then from the center upwards, because it's the minor axis, that would be B. Then from the center downwards, that would be a B. Then your C would be from the center all the way up to the focus. Okay. And we need to find our B. So do we have our C? Do we have our A? Of course we do. Let me just rub this off. Okay. Yeah. So do we have our A? Do we have our B? Do we have everything else? We don't have our B. So we have A squared. Hold on. So we have A squared should be equal to B squared plus C squared. We have our A. Our A is just the distance from the center all the way up to the vertex. Not necessarily 3. 3 isn't A. Okay, we don't start from the origin going up to here, then we say it's 3. No, no. We start from where it's centered at. So from -2, let us count how many units up until 3. Okay, so from -2, that would be 1, 2, 3, 4, 5. Okay, So meaning our a is 5 squared. So that is 5 squared. Then what about our b? That's what we're looking for. Then our c is from the same center up to the focus. Okay, so let's count. So there will be 1, 2, 3, 4. Okay, so our c is 4 squared. So what we're now going to do is, let me carry on solving from here. Excuse me. So let's make b the subject of the formula. So we're going to have b squared should be equal to 5 squared minus 4 squared. Okay, then this would be, what is 5 squared? That would be 25. So squared, so that would be 25 minus 4 times 4, that there would be a 16. Okay, so 25 minus 16, that would be a 9. Okay, so this is b squared should be equal to 9. Then we take the square root, we cancel that out. So b is equal to the square root of 9, that's 3. So meaning, going back to our graph, okay, meaning starting from here, the center, this from here to here, that is our a. From here to here, the focus, that is our b. Then our c is from here 3 units up and 3 units down, because that's what our b is. Okay, so let's move up by 3 units. So this here is 1, this here is 2, this here is 3. Then this would be a 4, this would be a 5, this would be 6. Okay, so starting from here, let's count. So this here would be a 4, 5, 6. So those are the 3 units. Then we do the same but moving downwards. Okay, so there, this would be a 4, sorry, this here would be -1, -2, and -3. That is our b there. Okay, then to draw it now, we're done doing everything. So to draw it, we'll just do that and connect the dots. Okay, so that there is our ellipse. So just for you to just write down everything that is needed. The minor vertices, you just locate this point and that point because they are the smallest. Okay, the major vertices, let me just do it so that we ensure that we cater everything and understand. So excuse me, starting from the origin going to the left, let's start with major vertices. Okay, major vertices, let me use a different color. We would have where this is located at x is equals to 3 and y is equals to what? 3. So that's 3 comma, actually these were actually given, yeah. So what we didn't have were the minor vertices. So the major vertices were actually given in the question, so I don't think it's appropriate to write them down. Yeah, so let's talk about the minor vertices. Where is this located at? This is located at -2 comma -3. Yeah, because we're moving 2 units to the left and 3 units downwards. So -2 comma -3. And let's focus on this one. Okay, and for this one, that's how many units to the left? Oh, my mistake, sorry, it's not located at -2 comma 3. I was acting as though this here is the origin. Okay, which is wrong. The origin is here. Yeah, that's where the origin is. So this here is located at -2 comma 0. Okay, -2 comma 0. Then this right here is located at 6. Okay, because I have to move 6 units up and 2 units to the left. 6 comma -2. So that's 6 comma -2. That's that. Then what about our focus? Where is it located at? It's located at the focus. They are located at 2 different points. So let's start with the one at the right. Okay, so that's this here is located at x is equals to 2 and y is equals to 3. Okay, so we moved 2 units to the right and 3 units upwards. So that's 2 comma 3. Okay, then for this one is located at, so we start counting from here going to the left on the x-axis first. So this is 1, 2, 3, 4, 5, 6. Okay, then how many units up? 1, 2, 3. Okay, so that's -6 comma 3. 86 comma 3. So that's that. We found everything. Oh, is it not the question they were asking for? It is. So I was doing everything so that we excuse me, just get familiar with it. So as we know it, this here is an ellipse, yeah. So let's write down let's first write down the general equation of an ellipse, which is x squared over a squared plus b squared over, plus y squared over b squared should be equal to what? 1. Now, of course, we're putting an a here because it's in the major axis. So, what we're now going to do here is, because this here is shifted, we're going to write this as x minus what? H squared plus y minus k squared over a squared plus, then we've got b squared should be equal to 1. Okay, let me just write the demarcation there. Then this is x minus, what is our h? Okay, that is where it is located in the x-axis, where the center is located at the x-axis. So in the x, it is located at -2. Then in the y, +3. Okay, so rather, let me even simplify it even further to make it easy. We say x minus h should not be equal to 0, but let's see. No, what I did there was just actually simpler than what I'm thinking. So this is x minus h there would be -3, actually -2, because we're moving 2 units to the left. So that's -2. Then we say squared plus y minus, what is our k? Where it's located? Actually, there's a mistake there. It is h here, the equation here, okay? Right here. The equation is x minus h. So that's x minus h, and our h is -2, okay? So it is -2 times -2, which is positive what? Positive 4. So this is a plus. Then for y, we do the same thing. So it is y minus k. Okay, now what is our k in this case? Our k is +3. Okay, it is located at +3 at the top there. So this here is +3 squared over, what is our a? Our a is 3. No, it's not 3. How many units did we move to the right? We had to move by 1, 2, 3, 4, 5. Yeah. So our a is 5. So this here would be 5 squared. Then our b, what is our b? How many units do we have to move up and down? So this is starting from the center. So this is 1, 2, 3. Okay. So this here would be 3 squared. Should be equal to 1. So this is our equation. We found everything. So let me just leave this question right here for you to just like try to solve it, because the more practical you are, the better. And at the end, your final answer is expected to be x minus 4 squared over 25 plus y plus 2 squared over 34 should be equal to 1. So this, you should expect to find this. Now let us look at shifted hyperbola. Okay, that's pretty much the last thing. Then from there, we're just going to look at rotated conic sections in the next video. And what else? Not shifted, polar forms of conic sections. Then we'll be done. So remember, the equation of an ellipse is just x squared over a squared plus y squared over b squared should be equal to what? 1. Okay. Then that of a hyperbola is slightly different. So this is x squared over a squared minus y squared over b squared should be equal to 1. So this is just the only difference, yeah? So meaning everything that I said regarding an ellipse is pretty much the same for a hyperbola, meaning we're going to have x minus h, x squared over a squared should be equal to, minus, open brackets, then this here is y minus k squared over b squared should be equal to what? 1. Okay, so yeah, let us just do some examples. So this here is not necessarily an ellipse but a hyperbola. So let's do this question. They're telling us, saying a shifted conic section, a shifted conic has the equation 9x squared minus 72x minus 16y minus 32y minus 16 should be equal to what? 0. Okay, so again, let us just group the like terms together and ensure that, okay, these tend to look more like a hyperbola. Okay, we need to rewrite this in the general equation. So we first group the like terms together, which I believe is the case already. So this here is 9x squared minus 72x minus 16y squared plus 32y should be equal to, this 6 goes to the other side, it's going to be negative 6. Now as you may see, this has a square and so does this. Then in front of this one right here, we've got a negative one, a negative there. Okay, so indicating clearly that, okay, this isn't a conic section that only has one square where we can call it a parabola. No. And neither can it be an ellipse. Why? Because there's a negative here. Okay, so it is expected to be a parabola. So in case they don't mention, just try to look for these hints. Okay, yeah, and it can be a circle, because for a circle it is x squared plus, okay, y squared should be equal to r squared. So this here isn't a plus but a minus, so we know what to expect. So let's factor out, let's deal with the x first, then we deal with this. So again, it is simpler that way. So let's take the factor out the 9. So factoring out the 9, we have 9, we open the parentheses, we say x squared minus the 9 times, what are we going to multiply times 9 to give us 72? It is 8. Okay, then we close. 8x, then we close. Then we do the same for this. So we say minus, let's factor out the 16. Okay, so 16, then we say y squared plus, actually this is a minus. Okay, yeah, because this minus multiply times the minus to give us the positive there. Okay, so yeah, factoring out 16 plus 16 is 32, so that's a 2y. Then we close, should be equal to what? Negative 6. Okay, then we can deal with the x first, then we deal with the y. So let's deal with the x first by completing the squares. So we say 9, then we say x squared minus 8x, then we leave a space. Okay, we say plus, then we leave a space. And what we're going to fill in this space is just half of what's in the middle, which is what? 2. Remember, there may be a negative here, but you're just going to put the negative there. Okay, so half of 8 is actually 4, sorry. So that's a 4 squared. Okay, yeah. Then what we're now going to do is, whatever it is that we've added on the left, we need to add on the right as well. We didn't just add a 4 squared. No. Because this 4 which we've added here has to multiply with 9. So meaning, or whatever it is that we're going to add. If we added maybe a 16 here, this would be 16 times what? Times 9. So in this case, it is 4 squared times 9. So 4 squared times 9. This is one thing. Then let's simplify it. Okay, we'll get back to this. Then let's simplify it. So this here simplified would look like, excuse me, we take the first letter, we take the minus, then we take the last one. So this here would be x plus minus, sorry, then 4 squared. Okay, then we say, yeah, actually we're done. Okay, so this again is just a simplified version of what? X minus 4 times x minus what? 4, of which when we multiply or rather expand, it will bring us back to what? To this. So we're done with this, with the x. Let's now deal with the y. Okay, so this here is minus 16 or negative 16, same thing. So negative 16 there. Then we say, we open brackets, then we say y squared minus 2y, then we say plus, we leave some space, then we close. What we're going to add here is half of what's in the middle. Okay, so and then we're going to square it. So what is half of 2? Obviously it's just a 1. So meaning we're going to add a 1 there. Then you say 1 squared. Now because we've added 1 squared on one side, we're supposed to do the same on the right, on the other side. Now this 1, we didn't just add a 1, we added a 1, and this 1 has to multiply with negative 16. So in other words, we've added 1 times what? Negative 16. So meaning it is plus negative what? 16. Let's simplify. Excuse me. Let's simplify. This is negative 16. Then we've got y squared here, minus 2y plus 1. So what we're supposed to do here is get the first one. We say minus 2. So we get the first one, then we get the last one as well. So this here is y squared. We say plus sorry, there's a minus here. Okay, then we say minus 1, then we square it. Okay, because this here is just a simplified version of this. We can try to expand that. So this here is 4 squared times 9. What are we going to have? By the way, I've forgotten something. Okay, in the equation, this is a 16 actually. Okay, this here is a 16. So meaning whatever it is that we took on the left, we have to take out a 16. Okay, so not a 6. This is a 16, 16. So the 16 was already there. Okay, so this was minus 16. Actually, this here is a minus 16. Okay, this right here, minus 16. So should it go to the other side, it's supposed to be a positive. So this here is positive, this here is positive, then so is this. Okay, sorry, so is this right here. So this just came with the original equation. We just had to take it to the other side. Then this here came as an outcome of what? This one. Because we introduced this one had to multiply with negative 16. And because we added negative 16 on the left side, we also need to add it on the right side. So 16 minus 16, that's just a 0. Then 4 squared, which is 16, right here, 4 squared times 9 would give us 144. So let's simplify this even further. Okay, we divide both sides by 144. We divide both sides by 144. So there into itself, that's a 1. Then we say should be equal to, then 16 into itself, 16 into 144. We're going to have a 9. Excuse me. So this here would be over 9. Then when we say minus, then 9 into itself, 9 into 144, that would be a 16. Okay, so this will be x squared minus 4 squared over 16. Yeah, over 16. So we have our equation now. Let's let's simplify it even further. So let's write this down in a more of a standard form. Okay, surely this is standard but not completely. Why? Because of the squares here. We can just add them. We need to simplify this and take them into their usual forms. So this will be x squared. Actually, this isn't supposed to be squared. So we've got x minus 4 squared over 4 squared, because 4 squared is the same as what? 16. Okay, then we say minus y minus 1 squared over, what is the simplification of this? Okay, 9. This here will be 3 squared. Okay, this here will be a 1. So this here is the standard equation. So let's just graph it and then we see where exactly it is located at. So this here is our graph. This here is 0, 0. Then let's first find its center. Okay, so let's first get this inside and equate it to 0, and we do the same for this and equate it to what? To 0. So this here is x minus what? 4 should be equal to 0, and y, actually let me first do it first. So now x would be equal to what? 4, because this 4 goes to the other side. So we do the same for y. This here is y minus 1 should be equal to what? 0. Okay, so y should be equal to what? 1, because this 1 goes to the other side. So we have our coordinates. Okay, and these coordinates tell us that x is what? 4, and y is what? 1. So we've got 4 comma 1. So on our graph, let's move 4 units to the right. That's 1 2 3 4, and 1 unit upwards for 1. So that's there, meaning that's where our hyperbola is located. Okay, that's where it's centered at. So let's look at our 4, okay, and our 3. So our A and our B, okay. In this case, our A is in the x-axis. Why are we calling this our A? It's the one with a positive. It's the largest, okay, and that is to say it is 4. So let us move 4 units to the right, okay, and 4 units to the left. So this here is 1 2 3 4 5, see, 6 7 8 9. The same goes for that. Okay, let's move 4 units to the right and 4 units to the left. We use a different color here. So we've got 1 2 3 4 and 1 2 3 4. Okay, yeah. Then let's do the same for b. Our b here is what? Is 3. Okay, so we're going to move 3 units up and 3 units to the left. Now, why are we going for up and down? It's because we've got our y there. Okay, so that would be 1, 2, 3. So this is 1, this is 2, this is 3, this is 4. So add 4. Okay, yeah, and 1, 2, 3. So this is -1, and this is -2, then this is -3. So it's going to stop somewhere at -2. Okay, so it's 1, 2, 3, yeah, at -2. So now what we're going to do here is we're going to draw a cube. I don't know if we should call it a square. Oh yeah, it's a square, not a cube. Touching all points. Okay, touching all points. So when we're done with drawing it, okay, let me just make it visible enough. Okay, what we're now going to do is draw a line. Let me go for red. Not red. Let's go with blue. Let me now draw a line that touches one corner, passes by the center, and touches the other corner. Then we do the same. This corner touches the center, goes to the other corner. So our line will look something like this. Okay, and the other one, excuse me, will look something like what? Like that. Then to draw our hyperbola, okay, to draw our hyperbola, wait, hold on. Let me just look at this nicely. So let's see. Yeah, so I think I've made a mistake somewhere, because if you look at this equation right here, this is -16 y squared minus 32. Okay, so it's just a matter of factoring out. So we've just been thrown off by a sign, so this is quite this would get complicated. So we need to ensure that we take note of the signs and avoid being thrown off by a simple sign. Okay, so just a simple sign has gotten us to draw a conic section that is completely different from what is expected to be drawn. Yeah, so take note of this. I've made a mistake here. This here is -16, this is -16, then this is -1, this is +1. Okay, so that there is supposed to be a negative. So the concept is the same, but just ensure that you maintain the sign everywhere. So everything I've just mentioned here is the same, except it was supposed to be located not at +1 but at -1. Here, this is where the center, this here, was supposed to be at. Okay, so it's just supposed to be here. Okay, yeah, but everything that I've done has to be done as it should be. And yes, with everything else that I've done, there's no mistake. It should be as it should be done. Okay, what's important is that you've understood and not what memorized. So let's draw it. To draw it, we just need to connect these lines. Okay, let me just use a different color. So starting from there, okay, you ensure that it just touches, then it touches the surface of this, and it also goes to the other side right there. Okay, the same goes to the other side. So starting from there, it just has to touch the surface, then it touches the surface on the other side as well. So this here would be the graph that we're interested in. Everything else that you see in color, the red, green, and blue, has to be drawn in a faint line, okay, because that's not what we're interested in. Then what about the focus? The focus is supposed to be located there and there, but how are we going to find it? Because we're dealing not with an ellipse but a hyperbola, we're not going to say a squared is equals to b squared plus c squared, but instead we're going to say c squared is equals to a squared plus b squared, where c is of course the same focus. Okay, so this here is, let me solve it from this side. So this is c squared should be equal to, actually, c is equals to, when we take the square root of both sides, this will cancel out, this will cancel out, the root of a squared plus b squared. Okay, in this case, what is our a? How many units did we move to the right? 1, 2, 3, 4. So 4, a is our what? Our 4. So this is 4 squared plus, what is our b? How many units did we move up? So that's 1, 2, 3. Okay, so we had to move 3 units up. So that's 3 squared. We take the square root there. So this is c is equals to, what is the square root of 4? That's just 16. Okay, plus, what is the square root of 3? That's a 9. And we add the 2 up, we're going to have our 25. Okay, 16 plus 9, that's 25. The square root of 25 is just 5. So meaning Going to our shape here, okay? This here, we're going to move 5 units starting from the origin. If you take C as your 5, meaning you're suggesting that your ellipse is here. So your focus is here, which is wrong, okay? So when you talk about A, saying A is 8 or B is 5, then C is maybe 20, okay? We're talking about how many times we're going to move starting from the origin. So in this case, our C is 5. So this is 1, 2, 3, 4, 5. Okay, somewhere at 9 here. Yeah, so that's where it would be located, right there. So meaning we also move 5 units to the left, do the same thing. This is 1, 2, 3, 4, 5. Right there. Okay, that's where it is located. And by the way, it has to be in line with the origin there. So it's not supposed to be drawn there. So yeah, there we have it. There and there. Yeah, so we need to just so everything I believe has been done as it should be, apart from just that negative sign that I had changed to positive. So that's just an error. I'm human as well, prone to making mistakes. So we now just have to write down the vertices. In this case, we've got this vertex and this vertex. Okay, what else? We can just like write it down. So these are the vertices. So we've got, what are we supposed to say? This here is the location of this. Okay, and by the way, it has to be in line with this line here. Okay, so it's supposed to be somewhere there. So that is located at the point 8 comma positive 1, because we had to move 8 units to the right and then 1 unit starting from the origin here, 8 units to the right and 1 unit upwards. That's where it's located. And what about this other vertex? Okay, right here, I had to move how many units, not necessarily how many units we had to move, but where it's located. It is located at 1 comma at 0 comma 1. So 0 in x, 1 in y. And what about the focus? We just do the same thing. We just find where it's located. Okay, so thanks for watching. Humbly request that you subscribe to the channel and ensure that you just become more practical, because these things are not as complicated as they may seem, as long as you're being practical. Thanks for watching. Have a great day.